Hello everyone, welcome to the paper discussion of your LTC MPL Chemistry Unit Test 7. So let's get started. The first question that came in the examination is the formation of cyanohydrine from ketone is an example of. Okay, so ketone is what? This. Okay, and cyanohydrine, formation of cyanohydrine takes place when cyanide ion, okay, when cyanide ion attacks. Okay, so cyanide ion attacks on this carbon and the electron will get shifted and the product will look something like this: CnO minus ion. Okay, which will certainly get O minus ion will certainly get converted to what? OH group, and there is a formation of cyanohydrine. Okay, so here if you'll see a negative charge, this is nothing but a nucleophile, is getting added to ketone, so hence it is a nucleophilic addition reaction. Okay, so 51, option number 1 is the right answer. Sorry. 52, C2H5Br, that is bromoethane, reacts with NaOH to give you ethanol and sodium bromide. It is a reaction in which, if you see, this OH minus ion has replaced Br minus ion, right? So can I say that it's a nucleophilic substitution reaction? So it is a nucleophilic substitution reaction. 53, tautomerism is not exhibited by, okay, tautomerism is not exhibited by carbonyl compound which does not have alpha hydrogen. All has alpha hydrogen apart from methanol. Methanol does not have alpha carbon, and hence there is no concept of alpha hydrogen for methanol. So that will be the answer. 54, which is least stable. Okay, stability of free radical goes from 3 degree carbon free radical to 2 degree carbon free radical, then 1 degree carbon free radical, and the last one is methyl free radical. Okay, hence we'll go with answer this, methyl free radical. Which of the following species is formed in homolytic fission? Homolytic fission, free radicals are formed. We'll go with option number 3. 56, this is group and this is electronic effect. OH is minus I and plus M, right? This is minus I and minus M. This is plus hyperconjugation and plus I. Okay, and this is also what? Plus I and plus M. Clear? So let us start. OH minus I minus I plus M. So 1 belongs to B. Okay, so 1 belongs to B. This is B, and 1, that is this. Okay, so the only option that suits in the example is this. So we'll go with option number 4. Okay. 57. Which of the following carbocation has no hyperconjugation? No hyperconjugated hydrogen. Okay, so here if you'll see, this is alpha hydrogen, alpha, alpha. So there are total how much? 1, 3, 3, 2, 8 alpha hydrogen. So there is 8 alpha hydrogen. That means 8 hyperconjugated hydrogen atoms are there. Here also we have alpha carbon, and hence alpha hydrogen is there. Here also alpha carbon and alpha carbon, again hydrogens are there. Here we have alpha carbon but no alpha hydrogen, and since this will be the best answer to select. So 57, option number 4. 58, the bond association energies of the following reactions are given. This is homolytic and this is heterolytic. Okay, identify the correct relationship. We know that heterolytic bond fission will require more energy than homolytic bond fission. Okay, this has to be the concept. Delta H2 is more than delta H1. We'll go with option number 2. Okay. 59. Column 1, column 2. Column 2 talks about isomers, whereas column 1 talks about what? The two different isomers. Okay, so dimethyl ether and ethyl alcohol. We can clearly say that functional group is changing. So A is 3. Okay, so A is 3. That means option number 3 is out of scope because A is 2. Aldehyde and ketone, they are not an isomer. So B is 5. So B is 5, option 1. So we'll go with option number 1. Okay. 60. The two structures 1 and 2 are. So let us draw this two structure. This is the front carbon atom. So this front carbon atom. Let us write it. Let us draw the structure over here. So the front carbon atom is CH3, bonded with back carbon atom, and back carbon atom consists of 3 CH3 group. So it's a neopentane. What about this? If I'll see the structure, it is CH3, this one. Then comes the front carbon atom, that is CH2. Then comes the back carbon atom, that is CH, and bonded to CH3. This is isopentane. Okay, so if you'll see, they have same molecular formula but differ in their structure. So obviously it's not a conformational isomer, right? Because their structures are different. Okay, it's not a stereoisomer as well. It's a constitutional isomer, that is structural isomer. So we'll go with 60, option number 3. 61, 0.32 gram of organic compound containing sulphur produces 0.233 gram of barium sulfate. Okay, percentage of sulphur in the given compound. So percentage of sulphur in given organic compound is given by 32 by 233 into weight of barium sulfate. What is the weight of barium sulfate? That is 0.233 whole divided by weight of given organic compound, that is 0.32 into 100. Okay, clear? So this is 32, almost 100 times, right? Wait, let's do it in a better way. So it is 32 by 233 into 233 into 10 raised to minus 3 into 32 into 10 raised to minus 2 into 100. So this get cancelled, this get cancelled. Okay, so 10 raised to minus 2 gone over there, become 10 raised to plus 2. So 10 raised to plus 4 into 10 raised to minus 3, that is equal to 10. So we'll go with option number 3. 62. Last night extracts of an organic compound, when heated with sodium nitroprusside, it gives a violet colored, okay, X, and X is what? Okay, so see, any organic compound, okay, this is sodium sulfide, where it is treated with sodium nitroprusside. What is sodium nitroprusside? Sodium nitroprusside, Na2 FeCl5NO. Okay, they both react to give you NF4 FeCl5NOS. Okay, so this is a compound that has been formed. Okay, clear? And this compound is violet in color. Okay, so this is the reaction over here. So we'll go with option number 1. Okay, 63. In Wood's reaction, N-hexane is obtained by N-hexane. Okay, you have to break it half, because N-hexane, you'll always get a symmetrical alkane from Wood's reaction. So it is N-propyl halide. So N-propyl will take N-propyl chloride. Okay. Which of the following compound will form a hydrocarbon on reaction with a Grignard's reagent? Okay, form a hydrocarbon. Okay, Grignard's reagent gets converted to, okay, RMgX gets converted to hydrocarbon, that is hydrocarbon, in the presence of a proton donor. In the presence of what? A proton donor. And out of all these things, the proton donor is alcohol. So we'll go with 64, option number 1. 65. Arrange the following in decreasing order of their boiling point. Okay, so 4 carbon atom butane. Butane plus methyl is 5 carbon atom, 5 carbon atom, and dimethyl propane 5 carbon atom. So 4 carbon atom and 5 carbon atom. That means this will be the last one. So if you'll see, all 3 options, A are last. That means A should not be the answer. That is 1 should not be the answer. Now, as the branching increases, the boiling point decreases. That means C should be having highest boiling point. Clear? So C is where? So option number 4. We'll go with option number 4. Clear? Now, C2H6 has been chlorinated and gives you A. So this is what? C2H5Cl, chloroethane. Chloroethane on alcoholic KOH will give you what? C2H4, that is ethene. Ethene on hydrogenation will give you what? again an alkane. So from where you started, you ended up at that particular point. So 66, option number 1 will be the best answer. 67. 1 mole of 2-butene on reductive ozonolysis gives. So CH3, CH, double bond, CH3, CH2. The first step is the addition of ozone in the presence of non-polar solvent, and then reductive ozonolysis is zinc in water. What is the shortcut? Break the bond, add oxygen. So you will get 2 CH3CHO, that is ethanol or acetaldehyde. So 2 moles of acetaldehyde. We'll go with option number 3. 68. Bayer's reagent is cold, dilute, alkaline, KMNO4. KMNO4 very dilute, cold, acidified. It's not acidified. It's not K2Cr2O7. Very cold, dilute, alkaline. Yes, this is the right answer. So 68, option number 3 is the right answer. 69. In dehalogenation reaction of dihalide, to get corresponding alkenes, the dihalide taken is vicinal dihalide, guys. So if you take a vicinal dihalide, something like this, and if you'll add zinc in ethanol, so you'll get what? A dihalide. Oh, sorry, an alkene. Okay, whereas if you'll take geminal dihalide, you are going to get what? Suppose if you are going to take geminal dihalide, you will be getting alkene but with the higher carbon atoms. Okay, and any dihalide or isolated dihalide is not possible, so we'll go with what? Simple vicinal dihalide. Okay, 70. The number of carbon atoms arranged linearly in but2-ine. So all are linear, right? They all are, since this angle is linear and this angle is linear. Okay, so all 4 will be what? In linear. Got it? CH3, CH2, CH2, Cl. Okay, so here alcoholic KOH means what? X is CH3, CH, wait. It is double bond CH2, right? Over here, CH2 double bond CH2. So the both are alkene. Okay, they both are what? Alkene. So they are pair of homologous. Yes. Have the same percentage of composition by mass of an element. That is also true. Okay. Have the same empirical formula. That is also true. So they all are true. That means all of the above. Okay. So this will be the best answer. Okay. 72. Acetylene undergoes addition reaction with. Okay. So NaNH2, Tollens reagent, and cuprous chloride. They all are what? Acidic. They are the reaction of what? It shows acidic nature of terminal alkyne. That is nothing but acetylene as well. Okay, clear? And hence the only option that left is 1. So 72, 1. 73. V2O5 is a red or orange in color. It is an amphoteric oxide. I have always said you so many times. Okay, amphoteric oxide. If you'll see your previous class test as well. Okay, this question is more frequent. It is amphoteric but shows most of an acidic character and less of a basic character. But yes, it is amphoteric. So 73, option number 3 will be the best answer. 74. Thorium is an actinide element. Its electronic configuration, okay, you know that its electronic configuration is found to be 7s2 and 6d2. Okay, so that will be the best answer. 75. Okay, these are the complex. This is the hybridization. NiCl4. It is a weak field ligand, and weak field ligand means what? No pairing, and no pairing means what? sp3 hybridization. Okay, so A is 2. So A is 2. So this is not the right answer. This is not the right answer. Fe H2O6 SO4. So again weak field ligand. That means no no pairing. That means H2O will go to sp3d2. That means B is 4. So B is 4. I'll go with option number 3. Okay, clear? Got it? Next, 76. Fructose is a reducing sugar. True. Fructose is a ketose. True. Let's go with option number 1. 77. The disaccharide is. Now if you'll see this disaccharide carefully, this over here, I remember this thing as bottom, bottom, up, or down, down, up, down, up. Okay, so if the configuration is like down, down, up, down, up, so it is a configuration for what? Alpha. If it is up, down, up, down, up, then this is a configuration for what? Beta isomer of glucose. Okay, so this is what? Down, down, up, down, up. So this is what? Alpha. Again, this is what? See, OH is at the bottom. So down, down, up, down, up. So again alpha. So alpha D glucose and alpha D glucose. They both are what? Alpha D glucose, and both are alpha D glucose. That means we are talking about maltose. Okay, because it will give you what? Alpha D glucose, in which in maltose C1 and C4. Okay, glycosidic linkage is present between what? C1 and C4 alpha D glucose. Okay, so this is maltose. 71. Glycerol can be recovered from spent lye with the help of the following technique. Glycerol can be recovered from spent lye by the help of vacuum distillation. 79. Acidic strength of an organic compound is low. Acetylene is more acidic than CH4. Rest all are what? More acidic than acetylene. Okay. 80. Organophosphates and carbamates are biodegradable. True. Organophosphates and carbamates are nerve toxins. That is also true. Okay, so true. That means both statement 1 and statement 2 are true. Okay. 81. Carboxyhemoglobin is 300 times more stable than oxyhemoglobin. Why? Because carboxyhemoglobin, here the ligand is about carbon monoxide. Oxyhemoglobin, here the ligand is about oxygen. And carboxyhemoglobin, that is carbonyl group, is a very strong ligand. Okay, and since it is a strong ligand, it forms a very stable compound with hemoglobin. So I'll go with option 3. Okay. 82. Water samples A, B, C, D, BOD values are 9, 6, 27, 81 respectively, most toxic. Okay, more the BOD value, more is the toxicity. So 81 belongs to D, option number 4. 83. CH2 act as a nucleophile. True. CH3 CH2 plus, that is ethyl carbocation, can act as an electrophile. True. Both are right. 84. Tollens reagent cannot be used to distinguish ethene and ethane. This is a combination. Ethane and ethene, this is the combination. It can be used to distinguish ethine and this. So ethane and butane cannot be distinguished, and ethene and ethane can be. So all these three combinations cannot be distinguished. Okay. Basically, Tollens reagent is used to distinguish terminal and non-terminal alkynes. It is used to distinguish what? Terminal and non-terminal alkynes. So see what are the options. A and C. Let me just remove it. So these are the possible things which cannot be distinguished by Tollens reagent. But according to options, we have to select. So let us see. Okay. A and C. A is what? Ethene. B is C is what? Ethyne. It can be distinguished because ethyne will give you positive test, whereas ethene will give you negative test. So this can be distinguished. B and C. Ethane and ethyne. Again, it can be distinguished. A and B. Ethene and ethane. They both do not give any reaction with Tollens reagent. So we'll go with what? A and B. Okay. So that is the right answer. 85. Maximum oxidation state exhibited by 3D element, okay, from Z is equal to 25. Okay, Z is greater than 25 in its oxides. Okay, see, you know that thing in the 3D series. Okay, from scandium to manganese, the oxidation state increases and then it starts decreasing, right? And then it starts what? Decreasing, right? So obviously, if it starts decreasing, the highest oxidation state is not possible. The lowest atomic oxidation state is possible. So greater than 25, let us talk about iron. Okay, it forms Fe2O3. The oxidation number is what? +3. Right? Clear? Then CO2O3. Here again oxidation number is what? +3. Right? So can I say that from from manganese outward, the highest oxidation state that can be achieved is what? +3. So we'll go with +3. So 85, option number 2 is the best answer. 86. The heat required to raise the temperature of a body by 1 degree Celsius is heat capacity or thermal capacity. Okay, that is the answer. 87. NH3 3H2. Okay, this is ammonia formation. Delta H is 46. kilocalories. From the above reaction, heat of formation of ammonia will be. Heat of formation of ammonia. Heat of formation of ammonia belongs to what? Formation of 1 mole of ammonia. But here how much mole is formed? Here 2 moles are formed. Right? So I have to divide the reaction by what? 2, and hence delta H will also get divided by 2, and hence you will get what? Minus 23 kilocalories. Okay, so minus 23 kilocalories. Okay, 88. For a given mass of a substance, internal energy will be maximum when it is in gaseous state. Okay, then liquid and then solid state. So the maximum is in gaseous state. Okay, 89. Hydration energies of lithium and chlorine are this and this. Okay, if lattice of this thing is this much, what is the enthalpy of solution? So enthalpy of solution, okay, of lithium chloride. Wait. Okay, enthalpy of solution is nothing but what? First lattice will break and then the hydration will take place. So it is what? Lattice enthalpy plus hydration energy. Right? So what is lattice enthalpy? 840 plus what is hydration energy? Minus 499 plus minus 382. So that is equal to 840 minus 499. So let us take it 500 approximately, and this is minus 382. So that is 840 minus 882. So that is around 42. That is, I have increased one, so I can decrease one. So 41 around. Okay, and that too what? Negative 41. Okay, so we'll go with option number 4. Okay. 90. The entropy values of methane, oxygen, carbon dioxide and water are this. The entropy change for the reaction. Okay, so entropy change we are going to calculate. Entropy change is what? Product minus reactant. So entropy of CO2. Entropy of CO2 is third one, that is 213.6, plus entropy of water is what? Twice into water is H2O, fourth value, that is 69.9. Let us take it 70 directly. Okay, I am taking 70 directly, minus entropy of CH4, where is methane, that is 186.2, plus entropy of oxygen, that is 205. So 2 into 205. Okay, so 213.6 plus 140 minus 186.2 plus 2 5s are 10, 410. So this is 400 and 500, 500 and then 600 approximately. This is approximately how much? 600. And over here it is 300 and 3, it is like 14, 28. So 328 around. Okay. So this will be around minus how much? 328 minus 600. So it will be less than how much? 300. Okay. Less than 300. And the range is somewhat around how much? 370 around. Oh, sorry, 270 around. 242. So yes, this can be the best answer. Option 2. Let's see. Yes. This can be the best answer in terms of 200. Okay. 91. At 0 degrees Celsius, ice and water are in equilibrium. Delta H is this. Delta S will be. See, at equilibrium, delta G is equal to what? 0. And hence, delta H is equal to what? T delta S. And hence, T is equal to what? What we need to calculate is delta S. So, delta S is equal to what? Delta H by T. That is 6 kilojoules. That is 6000 joules, because here it is kilojoules and the answer are in joules, by 273. So even if I take it around 300, okay, so this is around 20 times, okay, mostly nearby 20. So we'll go with option number 1. Okay. 92. Which of the following is not a spontaneous change? Not a spontaneous change. A gas expands to fill all the available volume. So it is a spontaneous change. Carbon bonds in oxygen to give spontaneous. Heat flows from colder to warmer. non-spontaneous, and hence that's the right answer. Okay. 93. Entropy of a perfectly crystalline substance at absolute zero is zero. Third law of thermodynamics, true. At absolute zero, transitional kinetic energy of a system is zero, true. So that is option number 1. Okay. Which of the following will have magnetic moment of 3.9 Bohr magneton? 3.9 Bohr magneton, that means approximately 4 magnetic moment. That means it should have number of unpaired electron is -1. So number of unpaired electron should be how much? 3. So let us see. Vanadium. Vanadium actual configuration is 4s2 3d3. 2 electron goes, so it is 3d3. So this can be the answer because it has 3 unpaired electrons. Chromium. Okay, chromium electronic configuration is 4s1 3d5. Okay, 4s1 3d5. So total electron, 3 electrons are gone, so it will be 3d3. Okay, then even this is the answer. Okay, cobalt 2 plus. Okay, cobalt 2 plus, if I talk about, it is 4s2 3d7. 4s2 3d7, so 2 electron gone, and in 3d7 there are 3 unpaired electron. Okay, in 3d7 there are what? 3 unpaired electrons, so it will give you this much configuration. Okay, it's like this. See, if you are not understanding, so let me just show you to you over here, just for my confirmation, so that you can understand. 3d7, 1 2 3 4 5 6 7. So see, 3 unpaired electron. Okay, clear. Manganese. Okay, manganese electronic configuration is 4s2 3d5. 3 electron gone, so it is 3d4. So 4 unpaired electron. It cannot give you. Nickel 2 plus is 3d8. Nickel 2 plus is what? 3d8, 2 unpaired electron. This cannot give it to you. Iron is what? 4s2 3d6. You remove 3 electron, it will give you 5. Okay, directly what? 3d5. So this will not give. So answer is ABC. Clear. So 94, option number 3 is the best answer. 95. Regarding samarium, okay, the correct statement, it is steel hard. True. Its melting point is highest among the lanthanides. True. Exhibit +2 and +3 oxidation state. True. Okay, all three are right. So we'll go with 95, option number 4. 96. The donor atom in glycine NATO is nitrogen and oxygen. So that is the answer. Okay. Which of the following is homoleptic, means having only single kind of a ligand? Okay, we can see in option number 1, it is only NH3 here, NH3 chlorine, NH3 chlorine, and NH3 chlorine. So we'll go with option number 1. The least oxidation state exhibited by actinide element in its compound is +3. Least oxidation state is what? +3. 99. Which of the following element is not an 5F series element? Okay, it is technetium. Okay, it's in 3D, it's in D block element. 100. The most stable carbocation. Okay, the most stable carbocation among the following. So over here, see, here it's a lone pair. It can donate directly to carbocation, and the what we say, the resonating structure that will be formed over here is something like this. And octet is completed of each and every element. So this is one of the case. Over here, suppose if this lone pair is there, even if it donates, okay, conjugation, okay, so this will not reach to this carbocation. Similarly over here, here there is a direct donation to a carbocation, and hence it will become more stable. So we'll go with option number 1. Clear? Sure. So guys, this was the question that was asked in your LTC MPL chemistry unit test 7. I hope that I was successful enough to explain you each and every question properly. Still, if there is any doubt left in your mind, please make sure that you are going to comment in this video and let us know what is the doubt, so that we can clear it up. Okay. So with this thing, guys, thank you so very much for seeing this solution video. God bless you all. We'll meet in the next video. Take care, guys.